This is the worksheet for 3.5 transformation of functions. This is the back side of the worksheet, 5, 6, 7, and 8. I did some of the ones in the front in class, so I want to go over the ones on the back. Let's start with this one. Okay, so we have a minus 2 that is attached to the x by these parentheses. So if the number is attached to x, it's going to move it in the opposite direction horizontally. So instead of -2, it's actually going to move to the right 2 spaces. It's going to do the opposite of what you would expect because it is attached. Okay, this 4 is detached from x. Okay, it's out there by itself. It is not attached to the x with any type of parentheses or radical or absolute value bars. So it is going to move as you would expect. So this is going to move it up 4 in the vertical direction. Now let me see if I can change colors. Let's go to green. First of all, let's just think about what the naked graph would be here. What would the basic graph for number 5 look like? Well, it would be just a y equals the cube root of x. That's what the naked graph for this particular problem would be. And then in your mind, you have to think about what the graph for the cube root of x would be. Now remember, this is odd, so we're going to be going through the odd quadrants. So the naked graph is going to go through quadrants 1 and 3, and it's like a sideways S. It's going to be kind of like this. What we need to do is we need to shift that graph right 2 and up 4. Okay, so go to the right 2, 1, 2, 1, 2, 3, 4. And this is my new focal point for my graph. I went to the right 2 and up 4 because that's what this says. Right 2, up 4. And then I need to duplicate what the naked graph looks like. So I need to draw a sideways snake. Okay. There we go. That's the new graph. Now we're going to talk about domain, range, increasing, and decreasing. Let's change colors for this. Let's go to purple. All right, domain are your x's. So you're going to read the graph from left to right for domain. I know I sound like a broken record, but we still have some struggles with this. So from left all the way to the right, this is the right, you're going to be going from negative infinity to positive infinity. In other words, this graph goes on forever in both directions. Okay, range. The range are your y values, and for the range, you read it bottom to top. Now, that's very important. This is a little bit harder to see, but even if you can't tell, this thing is going down infinitely to negative infinity, and it is also going up infinitely to positive infinity. So the range is also negative infinity to positive infinity. Okay? And then let's change colors for increasing and decreasing. Remember, increasing and decreasing is where we talk about that roller coaster. So you always sit down on the ride on the left-hand side. So here's my little person sitting down. And you're going to ride the roller coaster forever. And your entire trip is going to be going up. Just because we have this special point here does not mean that it changes directions. That is not always considered a turning point. Your body is still going up, 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 up the entire time. So it would be forever increasing from negative infinity to positive infinity, and it would never decrease, or you can put never or none. Okay, so that's number 5. Let's try number 6. Let me go back and get our colors. We're going to use red for our transformations. Okay, this plus 2 is attached to x. This plus 2 is attached to x by parentheses. So it's going to move it in the opposite direction from what we would expect horizontally. So since this is a plus 2, it's actually going to go to the left 2. Okay? This number is detached. It is detached from x. So it is going to move as we would expect vertically. And since it's a positive, we would expect that that would move it up 3, and that's exactly what's going to happen. It's going to move up 3. And this has an amazing little trick. It has a negative in front of the function. So what that's going to do, if it is in front, it is going to flip it. Okay, it's going to flip it. So in other words, remember, if it was praise hands, that would be a positive x squared. If you put a negative in front of the x squared, it would flip down. Okay, same thing here. Now, before I continue, I need to get in my mind what the naked function looks like. So let's go over here and just write it down. The naked function for number 6 would be y equals 1 over x to the 5th. That is just the basic function before you added a negative, before you added a 2, before you added a 3. This is the naked function. We have x in the bottom, and 5 is odd. So we know what that looks like. It's going to go through the odd axis, quadrants 1, odd quadrants, sorry, not axis, odd quadrants 1 and 3. So this is the naked graph. The naked graph was centered at the origin. Well, we now have a new center point. So let's graph. Let's see. We're going to go left 2 and up 3. So here's the origin. It's kind of hard to see on this graph paper. Left 2, up 3. So this is our new sort of origin. Not origin, that's not the right word, but it's kind of the point of symmetry for this particular graph. Now, I want to remind you, and this is something we have not spent a ton of time on, but you cannot cross, I'm going to highlight this, you cannot cross this point horizontally or vertically. So I'm going to dot this up. You cannot, and this is a really fat highlighter, I didn't mean for it to be that big, but you cannot cross that point of symmetry. So we cannot cross it. Not only that, but we need to flip this down. So what's going to happen is this component is going to move up and this side is going to move down. Let me get rid of that highlighter because that is awful to write with. Let's go back to green. Okay, so I got a lot to think about here. This is my point of symmetry, and I need to flip this down, but I can't cross the yellow lines. So quadrant 1 is going to flip down and actually be predominantly in quadrant, oh, I got really close to the yellow line, 4. And then this 3 is going to flip up and be predominantly in quadrant 2. Now remember, these need to be curves. You cannot make these 90 degrees. That is wrong. So there is my new graph. Now look at that really good. We flipped it because there was a negative in front. We moved it to the left 2 and up 3. And again, this was my naked graph that I'm shifting. There's a lot going on there. That's a pretty difficult problem. All right, domain and range is also pretty challenging. You have 2 sections of this particular graph. And remember, domain are your x's. So if you look at this thing horizontally, it's going to come all the way to -2 and then stop. So the first part of my domain is going to be from -infinity to -2, and then it's going to stop. It gets a parenthesis there because it does not touch -2. Then I have to unite it with the second part of my graph. So the second part starts at -2 and goes all the way to +infinity. So in other words, the only point of the domain that is not included here is, oh, that's supposed to be a negative, is -2. You want to know why? Sure you do. Because if you go up here, -2 plus 2, if you put a -2 right here, you would end up getting 0 in the denominator, and we know that that's a no-no. So that's why we have that restriction right there at -2. Okay, the range is very similar. So the range, you're going to come up all the way until you hit almost 3. So the range is going to come from -infinity up to 3. You put a parenthesis because it never actually reaches 3. And then you unite that with 3 and up. So 3 and up would be the second part of your range. Okay, again, because there are 2 parts to the graph, we're going to have 2 parts to the domain and the range. And that's not always the case for this particular problem, I should say. All right, let's go to my blue pen, and we will finish this up by talking about increasing and decreasing. Now, you have two separate rides here. It's like the killer and the thriller. Okay, the thriller, you get on here, and it's going to take you all the way up for all eternity. You're going to be increasing. Now, remember, your turning point is this x coordinate, which is -2. -2 is where your body changes. So from negative infinity all the way to -2, your body would be increasing. Okay, same thing down here. You get on the ride at the left, and you're going to ride it up. This side is also increasing. So we actually have two sections of the graph that are increasing. So we're going to unite that, and the second part of the ride goes from -2 to positive infinity. And nowhere on this example would you be going down. So for decreasing, we put none. That's about as hard as it gets, but that's pretty complicated. Okay, I'm about out of time, but I'm going to just graph these two for you, 7 and 8, and then let you answer the questions. So let's look at 7. I have a +2 attached, so it's going to do the opposite, which is left 2. I have a -3 detached, so it's going to do as I would expect, which is going to be down 3. And then I have a negative in front, and the negative in front is going to flip this down. Now, before we do any of that, let's think about the naked graph. The naked graph would be just the plain absolute value of x, and we know that is a perfect V centered at the origin. So we're going to make our shifts and sketch it. Let's see. We need to go left 2 and down 3. So let's go left 2, down 3. There we go. And then we also need to flip it. Because of this negative in front, we're going to flip the V down. So it would be perfectly centered. And it doesn't have a number in front, so it didn't get wider or more narrow. It's not stretched or compressed. And it doesn't look like I have an example on the back of where the negative is attached. I probably need to change this, but for now I'm going to have to go with it. So let's look at this one. This is another negative that is out in front, okay? It's out in front. This -1 is attached, so it's going to do the opposite of what we would expect. I would expect it to do -1, but it's actually going to go to +1. And then this negative is going to flip it. Now, before we proceed, let's look at the naked graph. The naked graph would be y = x cubed. Since this is odd, we're talking about quadrants 1 and 3, and it would look something like that. I need to make my shifts, so I'm going to go to the right one, and then I need to flip it. So what that means is, let's change our colors here. If I flip it, this comes down to quadrant 4, and this flips up to quadrant 2. So my new graph is going to be like such. Okay. This graph, I'll just go ahead and tell you this. This graph is going down forever. This is a constantly decreasing graph. So it would be decreasing from -infinity to +infinity. It would never be increasing, so you would put none there. On the reverse side, this graph has 1/2 of it would be increasing, and then the right-hand side would be decreasing. Okay? So that gets us most of the examples done on the back side of that worksheet. Practice, practice, practice.